Alright, so this is going to be the quick video for review sheet number 15. Okay, so I'll kind of go through what work I require and kind of help you out with some of maybe the things you haven't learned yet or we've just learned. Okay, the first one here, you guys all know how to do this. I know that a lot of you can even do it mentally, but I want you to be showing your work here. So on this one, if you don't remember what work I would require, you could look back to your chapter 3 notes. It was in what's called the 5th grade review section, which was like on page 2 of your chapter 3 notes. So you can go back there and you can see exactly what I'm talking about, but I'll show you one here. So I'll just do this one. So if I'm doing 12 divided by 5, I actually got to show that because all fractions are division problems. Okay, so you ask yourself, how many times will 5 go into 12? That'll be 2. Then you multiply, then you subtract. Now, here's where I saw people doing throughout the week. A lot of you were then adding a decimal and doing all this stuff. You don't have to do that. We're not turning it into a decimal. We are just turning it into a mixed number. So what we do is, remember in elementary school this would have been 2 remainder 3. It's not that anymore, but, I'm sorry, 2 remainder 2 is what I meant to say. Okay? We wouldn't do that anymore, but that's essentially the same thing because what you're saying is you have 2 pieces remaining out of, and then if your denominator was 5 there, then it stays 5. Okay, so I will require that work. If you don't have that work on when we grade it, it will be incorrect. Okay, so I just need you to just show that division, and that remainder becomes the numerator. That's all. Okay, here you're finding the sum, difference, product, and quotient of mixed numbers. Probably the first thing I would do if I were you is I would say, first of all, you can't multiply or divide mixed numbers without converting them into impropers. You can do it with adding and subtracting, but my thing is, if you're going to have to do it, why not just do it once? So what I mean by that is I went ahead and changed it, went around the barn and made this 34/5, and then I made this 12/5, like that. Then all I'm looking at is I'm looking at it going, okay, I'm just going to add those, then I'm going to subtract those, then I'm going to multiply those, then I'm going to divide those. Okay? And then from there it's pretty easy. Quick reminder, just keep in mind that when you're adding and subtracting fractions, remember you must have something in common. The denominator must be a common denominator. When you're doing product and quotient, product's probably the easiest one out of all of them. Quotient, remember, you have to do that algorithm that we learned. Again, look back to chapter 3 if you have any issues there. Okay? Number 3. Which of the following does not have a unit rate of $14 for one CD? So here's the deal. On this one, I need to see 4 proportions on your paper. Okay? If you don't have it, it'll be wrong when we grade it. You must have 4 proportions. There we go. Because we're doing a unit rate, we know that we're putting 1 in the bottom right, so 1, 1, 1, okay? And we know that we're talking about 1 CD, so that means my labels here are going to be CD, 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 and that means that money would be in the top, and I won't go through and put money in all the top, but then that's easy. Then this, obviously right here, that's what I would call your fake ratio, $28 for 2 CDs. Divide 2, divide 2, oh, $14. Does that have a unit rate of $14 for 1 CD? Yep. So A is true. But remember, we're trying to figure out which one does not. So you need to have 4 proportions there. If you don't have them, wrong. Okay? This one, I think I've made myself very clear on the expectations here. 1-step rewrite. Everything you do, make sure you write PEMDAS. Okay? Remind you that every single week. And then 1-step rewrite. So, pretty easy there. Okay, this one, now it says use a proportion, so again you have to have a proportion. Now I made it for you there. Now one thing to keep in mind though is anytime you have this kind of stuff right here, we're talking about a fake ratio. Now that's exactly the way you've learned it everywhere we've gone, so this is no different. The ratio of red to yellow is 3:2, so we're going to have 3 reds, we're going to have 2 yellows, which means we have 5 total. Always need to do edge pieces. Now you go to your real, notice I'm doing that in green because that's the way you guys have known whenever I started talking about real information, I put that in green. I put the fake information in yellow. Okay? Now, if you have 85 Skittles, so you have to determine, is that 85 representing the amount of reds, yellows, or total? Hopefully you're all saying total because it just says Skittles, so you could change that word to total, and then you just set it up. We got total on the bottom, and then what's it asking for? Yellows, so it means yellows up top. Remember this right here, the ratio on the left is always your fake ratio, which goes with your edge pieces and your fake information. Okay, and then you'll just plug in your real information and then solve. Okay. We've done a bunch of these, but if you need to look back to learning target number 2 to help you on that one, you can. Just keep one thing in mind. If you need to draw a number line, it's not a bad idea. Okay, but you got to make sure you always put 0 degrees on that number line. So if I'm going from negative 12 degrees all the way up here to 32 degrees, since I'm going across 0, I'm going to be adding their absolute values. Okay? Whereas if I'm staying on one side, so here I got negative 6 and negative 12, I'm doing this one right here. Since I'm staying on one side, I'm just going to subtract their absolute values. Okay? I'm here. We've done a bunch of these. This is all chapter 1. You can look back to your chapter 1. Matter of fact, this might have been a chapter. I think this was on the chapter 1 summative or formative, which you may still have your tests. Most of you probably threw them away from chapter 1, but you know they're in your notes too. In your notes, so you can definitely get it there. Your keyword is right there. That was one of those buzzwords we learned. Okay, and then if you figure out that, then it makes it pretty easy after that. I think you can figure out the rest of it. You just got to figure out what it's talking about when it's talking about greatest. Okay. Mean, median, mode, and range. Okay. Done these pretty much every single week. Mean is the one where you're going to add up. Oh boy. You're going to add up all your temperatures in this case, and then divide by however many there are. And that's going to be your average. Can be a decimal. It will be. I think it might actually be a decimal. I can't remember, but regardless, it can be a decimal. You can have decimal temperatures. Median, you're going to need some work on that one. That's the one you're going to have to list them least to greatest, and then you're going to cross off the smallest, the biggest, smallest, biggest until you get to the middle. Okay. Mode, remember, is the most occurring number, so it's the number that occurs most often. Okay. And it is possible to have no mode. You don't have to have a mode for every set of numbers. Okay. Range is the maximum minus the minimum. So again, something we've covered pretty heavily here lately. You have to figure out which one of these is true on this one. So you're looking at it going, well, if you forgot what those bars are, you're going to need to look back to chapter 2. Okay? If you remember, that means absolute value. And the absolute value is always positive. So in this case, we are saying that 45, because the absolute value of negative 45 is 45, is greater than the absolute value of 63 is 63. We're asking, is that true? Is 45 greater than 63? Clearly not. Okay? So you have to figure out which one is true. Okay? This is what we're doing right now. As you can see, here's your fake ratio. We don't have edge pieces here, but you could. Okay? You could actually have an edge piece where it's saying that for every 4 apples, there are 3 orange juices, which means 7 total. You could definitely do that. But the model's already there for you. If Megan uses 520 milliliters of apple juice, so I know that the 520 is just representing the bar that's representing apple juice. So I'm going to do, I need to figure out, I don't want to tell you, but you're going to have to figure out what one of these little boxes is. That's the whole point to bar modeling. We're trying to figure out, well, what is one piece? If I can figure out how many milliliters is in one of these, then I can figure out how much orange juice I need by just multiplying it by 3. Okay? Let's go ahead and go to the back. Okay? I'm going to definitely need to see some proportions. Okay? Now there's a couple different ways to show your proportions. Like if I was showing you A, I'll show you in 2 ways. What you could do is you could take your fake ratio, which you know is that unit rate, 50 miles per 1 hour. And then what you could do is you could just pick the number of hours and just plug it in. and actually solve it. So then you'd say, okay, well that's times 10 times 10. That would be 500. Okay, so is that going to be true then? No. So that one is no. Now the other way you could do it, so I'll put or, so you can use this method too, is you always can do this. You can always just set it up and go, okay, this is my ratio that I'm basing on. This is my fake ratio. I want to know if it's equivalent to this ratio in 10 hours. And then you just look at it and you say, oh yeah, Mr. Garrison in chapter 4 taught me 4 methods to checking for equivalency. Okay, one of those methods was just seeing, okay, are you multiplying or dividing by the same number? Well, here I know I'm multiplying by 10. There I'm definitely not multiplying by 10. Okay, I'm multiplying by something greater than 10. That's one way to do it. You could also simplify them both. Okay, you could also divide them both. You could also do cross products. So 1 times 700 is 700. 10 times 50 is 500. Clearly, these are not equal to each other. So no matter how you do it, you can just plug it in. You could just take that one and just plug it in and then solve it to see what it actually equals if we traveled 10 hours. Or you can do it this way. It does not matter. Okay, either way, but you must have one of the two. You must have 4 proportions here. If you don't have 4 proportions, it's wrong. This next question, this is actually going to be a bonus question this week. So I'm not going to help you a whole lot, but here's the catch. If you don't attempt it, it's going to be wrong. If you don't attempt it, it's wrong. But I want to see what you guys can do on this, okay? Okay, so if that's not going to, if since it's bonus, I'm not going to help you with it, okay? But it has to be attempted. And then if you get it right, you get the bonus point. All right, go to the next page. Okay, this question is going to be exactly like this one right here, the one we did here. Same idea. So the only difference is you got a heck of a lot more options to choose from. So you have 1, 2, 3, 4, 5, 6, 7. You need to have 7 proportions here. And you can do it either way. The same ways I just gave you on that previous page, you could do, because right there's your fake ratio. I don't care how you do it, but you're going to use that. You can either set up a proportion, or you could do something like if I did A here, I'll just show you. If I did 50 cents per avocado, and then I just say, oh, well, I'm just going to figure out how much 6 avocados cost. Just figure it out. And this is what I'm trying to figure out. How much does it cost then? And if it's 3, then we know A is one of the answers. Times 6, yeah, that's going to be $3. So I know A is one of the answers. Or, just like over there, you can do it the same way, where you do 50 cents per avocado, and I know that the ratio they gave me was $3 for 6 avocados, and then you could just do your 3 methods. You could use cross products. 1 times 3 is 3. 6 times 0.50 is 3. So far, so good. Simplifying actually will not work here because you cannot have a decimal in a fraction. And when you type in using the ABC button into your calculator, it will say error because you can't have a decimal. So actually simplifying won't work when there's decimals involved, but that's okay. You could still divide it. 0.50 divided by 1 is going to be 0.50. 3 divided by 6 is going to be 0.5, which is 0.50. They're the same thing. So yeah, absolutely. We learned they were equal. So either way is good, but you need to come here and you need to be proving these true or false. So 7 proportions. If you don't have 7 proportions, wrong. Okay? Now this one here, I'm going to give you the option on this one. You could have 4 proportions. That's how I would like you to do it. If you haven't figured it out, proportions are kind of something that we like to stress, so we're making you do them, and they really should make your life easier, not harder. Okay? So we have 4 proportions. You could do 4, so that means you could take this, since this is a given information right here, and so is that. Those are the 2 given. You could use either one of those as the fake ratio. Okay, it doesn't matter. Okay? Or, since this is a table, we did in Chapter 4, Learning Target number 2, I believe, we learned how to scale within the table itself. So you don't have to do proportions, or you could just use the ratio table, which would be, oh, I know, what am I doing to go from 2 hours to 6 hours. Well, I'm multiplying by 3. So what am I going to do to $13? Okay. What did I do to go from 6 hours to 1 hour? Well, I divided by 6. Or you could say, what did I do to go from 7 hours to 1? Either way, I'm cool with the ratio table way or 4 proportions. Okay. These two, in simplest form, what is the ratio of rectangles to stars? Pretty basic there, I think. Just remember, order matters, and just keep this in mind right here. Simplest form. Okay. And last one, which is not another way to express the ratio of all figures to rectangles. You should know there are only 3 ways to write a rectangle. That's Chapter 4, Learning Target Number 1, if you're not sure. But there is one of those that really makes no sense at all when we're talking ratios. Alright? Alright guys, I hope it helps. See ya.